Welcome viewers, in this video we will see the characteristics of a DC motor. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive, the link is given in the description box. The characteristics of DC motor is discussed in the three different quantities. The first one is armature torque, second one armature current, and third one is speed. So based on the three parameters armature torque, armature current and speed, we can categorize the three different characteristics. The first one is the armature torque versus armature current. It's called a electrical characteristics. Second one is speed versus armature current. The third one is speed versus armature torque. That is called a mechanical characteristics. These three characteristics are given by the two different equations, two different relations. TA is directly proportional to pi into Ia. Armature torque is proportional to flux into armature current. The second one, N is directly proportional to EB by pi. Speed is proportional to back EMF divided by back EMF and inversely proportional to flux. So based on that, we can analyze the characteristics of a DC motor. First we will go to the series motor, characteristics of a series motor. So the first characteristics is armature torque versus armature current, TA versus Ia. So we know that TA is directly proportional to pi into Ia, that is the basic relation. But in case of the series motor, pi is directly proportional to Ia. There are two cases available, before saturation and after saturation. First we will see the before saturation. Before saturation, normal case. The pi is also directly proportional to Ia, because in series motor, field coil, armature, load all are connected in series. Same current is flowing through the field also. So that pi is directly proportional to Ia. So that TA equal to pi into Ia. So the pi is replaced by Ia into Ia. So Ia square. So TA is directly proportional to Ia square. So the torque is directly proportional to square of the armature current. So that is nothing but when the armature current increases, the torque will increase in a parabolic manner like this, not a linear, parabolic manner. So that is given by this. This is similar to the equation of parabola, y equal to mc square, y equal to mx square. So x increases in a parabolic, the y increase in a parabolic manner. So the curve will be in a parabola. It is not a linear, it is in a parabolic manner. Series motor used where high starting torque is required for accelerating heavy masses like quickly, as in the case of crane, hose, electric trains. So the series motor using for high starting torque. It is started with a loaded condition. That is a very important point. It is started with the loaded condition. So after saturation means the machine attained the full speed, the pi is independent of Ia. Previously when Ia increases, pi also increases. Once it is attained the saturation, this Ia and pi will be independent. So the pi is almost constant. In that case, TA is directly proportional to only Ia. TA is equal to K into Ia. So this is very similar to the equation of straight line. So the curve also become the straight line after saturation. So before saturation, the curve is parabolic. After saturation, the curve will be in a straight line. Now we will go to the second characteristics, speed versus armature current. We know the relation N is directly proportional to EB by pi. Back EMF and flux, inversely proportional to flux. But the back EMF is given for a series motor V minus Ia into Ra plus Rse, because the armature is connected in series with the field winding, so that we can take Ra plus Rse. So Ra and Rse is very small, so that Ia, Ra plus Rse drop does not change much variation with the load. These two values are very less. So the totally this value, this drop will be, is very less, it will not vary with the load. so that we can neglect the term Ia into Ra plus Rse because of small drop. So Eb is Eb is equal to only V. The back EMF is proportional is equal to only the terminal voltage. This term is neglected. So that N is directly proportional to 1 by pi, because this Eb is V, that is almost constant. The applied voltage is constant. So now see the relation when the speed and flux are inversely proportional, right? When the flux increases, the speed will decreases, right? So that is given here. So in series motor, pi is directly proportional to Ia, so that N is directly proportional to 1 divided by Ia. This pi is now pi is directly proportional to Ia, so that we can replace this pi with the Ia, right? So N is inversely proportional to pi, but pi is proportional to Ia, so that we can write N is directly proportional to 1 divided by Ia, or inversely proportional to Ia. So when the armature current increases, the speed will decreases. As the load increases, the Ia will increase and speed will decrease, because both are inversely proportional. When the armature current increases, the speed of the motor will decrease. But when load is on the series motor is completely removed, Ia falls to very low value and the speed is dangerously high, because if it is not started with the load, the Ia is very less value, so that the speed will be enormously very high. So that series motor should never started at the no load condition. It is always started with the loaded condition. The series motor is called variable speed motor, and it is adjusts the speed according to the load. So that, because if the Ia falls to 0, very low value, this Ia is proportional to flux. The flux and speed is inversely proportional. The flux is low, the speed will be high, speed will be infinite. N is directly proportional to 1 divided by pi. The pi is available in the denominator. If the pi value is lesser, means N value will be very high, so that speed will be dangerous. So that it is always started with the loaded condition. If it is no load, means Ia falls to very low value, flux also very low value. The flux is very low, mean the speed will be very high. Now we will go to the third characteristics, N versus Ia, speed versus armature torque. It is obtained from the above two plots. From the previous plot, we can draw this speed versus armature torque. Now take the armature current equal to 1 ampere, find the corresponding value of TA and N from the previous curve. Locate this plot, point on the graph, N versus TA. Similarly, consider different values of Ia and obtain the values of TA and N and plot on the same graph. So this will give the N versus TA characteristics. That is almost, it is inversely proportional. This TA, when TA increases, the speed of the motor also decreases. When the torque increases, the speed will decreases. So from previous two curve, by giving the different values, we can able to obtain this, the third curve, which is clearly given that it is inversely proportional. So in this video, we discuss about what are the characteristics of a DC motor, then characteristics of DC series motor. 3 different characters we discuss. Subscribe the channel for more videos. The soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. Welcome viewers. In this video, we will see the characteristics of a DC shunt motor. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we will go to the topic. The first characteristics is armature torque versus armature current, TA versus Ia. So we know that the relation between TA and Ia is TA is directly proportional to pi into Ia. Armature torque is depends upon the flux and armature current. But in case of shunt generator, the flux is constant. The flux is almost constant. So the armature torque is directly proportional to only armature current. TA is directly proportional to IA. So, that can be written as TA equal to K into IA. K is the constant. So, both are proportional to each other. When IA increases, the torque also increases. So, that is given in the graph. When the armature current increases, the torque also increases in a linear manner, because this is similar to the equation of straight line y equal to m into x. So, due to that the curve also a straight line because of linear, and similar to the straight line equation of straight line, the curve also a straight line. When armature current increases, torque also increases. The shunt motor are not started on heavy load because they need high starting current, which will affect the voltage regulation and the electrical installation. So, the shunt motors are not started with the heavy load. After started, the load can be gradually increased, otherwise it will take the large amount of current that will affect the voltage regulation as well as the electrical installation. But series motor can be started with the loaded condition. Now, we will go to the second characteristics, speed versus armature current, N versus IA. Speed versus armature current. So, we know that N is directly proportional to EB divided by pi. The speed is directly proportional to back EMF and inversely proportional to flux. But in shunt motor, we know that the flux is constant. So, the speed is directly proportional only back EMF. But the back EMF is given EB equal to V minus IA into RA. So, this RA is very small. So, that IA RA drop also very small, so that we can neglect the term IA RA. So, that the EB is directly EB is equal to only voltage. This applied voltage is almost constant. This voltage also constant. Therefore, speed also constant, right. So, the here speed is depends upon the back EMF and pi is almost constant. By analyzing the back EMF equation, this drop is very less, so that it is neglected, only depends upon the V, but V is also constant, so that EB also constant. So, the speed is almost constant. See this, when the armature current increases, the speed is almost constant, slightly reduces due to some losses, due to loss and friction, there is slightly reduces, that is almost nearly constant. So, from this we are able to analyze that when the armature current increases, the speed is almost constant, because the back EMF and pi also almost constant. But when flux and EB back EMF decreases with increase in the load, if you increase the load, the flux and back EMF will increase. So, decrease in the EMF is higher than the decrease in the flux. So, if the decrease in the EMF is higher than the flux. So, the speed will decreases slightly with the increase in the load. But for all practical application, the shunt motor is called almost a constant speed motor. This will be compensated. If while increasing the load, pi and EB will changes, but it will be compensated. So, it is almost a constant speed motor. Shunt motor is also called a constant speed motor. Now, we will go to the next characteristics, speed versus armature torque, N versus TA. So, this can be obtained from the previous two curve. For the different values of armature current, find the value of armature torque, speed from the previous two curve, then we can draw the speed versus armature torque curve. So, this is also almost constant. When the armature torque increases, the speed is almost constant. So, there is a slight dip in the speed, other than that it is almost constant. So, this one can be obtained, this characteristics is obtained from the previous two characteristics. So, in this video we discuss about the characteristics of a DC shunt motor. Three different characters we analyzed. The first one is the armature torque versus armature current, second one speed versus armature current, third one speed versus armature torque. Subscribe this channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. Welcome viewers, in this video we will see the characteristics of a compound motor. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we will go to the topic. The compound motor means we have series field as well as shunt field, both are available. So based on the connection, it is divided into cumulative compound and differential compound. First we will see the cumulative compound. Cumulative compound means series field is added with the shunt field. Both are added together. Series field flux is added with the shunt field flux. In that, first we will see the armature torque versus armature current, TA versus IA. So as the load increases, the armature current will increase. So that the series field current also increases because all are connected in series. And flux in the series field winding also increases. Load increases, armature current increases, series field current also increases, so that the flux in the series field also increases. We know that the flux, total flux equal to sum of flux due to shunt and flux due to series, pi SH and pi SC, shunt field flux and series field flux. If the pi increases, the pi SC increases mean the total flux also increases. So as the load increases, armature current increase, the total flux also increases. So we know that TA is directly proportional to pi into IA. So here pi also increases, IA also increases, both are increases. So that we will get the graph in a parabolic manner. When the IA increases, the torque increases in a parabolic manner because these are this pi and IA both are increases. Increase in TA is rapid because of both pi and IA also increases, right. So load increases, the armature current increases, the total flux also increases. So T is pi directly proportional to pi into IA, both are increases in a rapidly, so that it will getting in a parabolic manner. Now we will go to the second characteristics, speed versus armature current, N versus IA. We know that relation N is directly proportional to EB by pi, back EMF directly proportional to back EMF, inversely proportional to flux. So when the armature current increases, series field current also increases, the series field flux also increases, so the total flux also increases. Just now previously we discussed. Load increase mean armature current, shunt series field current, series field flux, the total flux will increase. See, the flux is available in the denominator, inversely proportional. If the speed increases, if the flux increases, speed will decrease. So the load increases, the totally flux is increasing, but the flux is inversely proportional to the speed, so that speed will decreases. So this dotted line refers the speed of the no load speed. When the load increases, the speed is slowly decreases, it gradually decreases. So that is due to increase in the flux. The speed decreases with the increase in flux, or speed decreases with the increase in the armature current. Now we will go to the third characteristics, speed versus armature torque. So this is drawn from the previous two curve. Find the speed and armature torque from the previous curve for different values of armature current, then draw the speed versus armature torque curve. From the previous curve we can draw this. So here also it is, when the armature torque increases, speed will decreases, slowly the speed will decreases. Now we will go to the differential compound motor. First we will see the armature torque versus armature current. The same thing, as the load increases, armature current will increase, series field current also increase, so the series field flux also increases. So the total flux is pi AC minus pi S, pi SH minus pi SC, because in a differential compound, series flux oppose the shunt flux. In previous case, both series flux and shunt flux are added together. Now it is subtracted. So So, when the series field flux increases, the total flux will decrease because both are subtraction, both are oppose each other. In previous case, both are added together. So, when the load increases, armature current will increase, but the flux will decrease. We know that relation T is directly proportional to pi into Ia, right. So, here Ia is increasing and pi is decreasing, but increasing in Ia is more than the decreasing in pi. So, that it is compensated. So, the TA is increasing slowly. In previous case it is increasing in a rapid manner, but here one parameter Ia is increasing, but another parameter pi is decreasing, but the decreasing is very less than the increasing of armature current. So, that still the armature torque will increases, slowly it will increases, right. So, when the armature current increases, the armature torque also increases. Now, we will go to the speed versus armature current. We know that N is directly proportional to EB divided by pi, directly proportional to back EMF and inversely proportional to flux. The same thing, as the load increases, armature current will increase, series field current will increase, so that series field flux also increases. But the total flux is difference between these two, pi SH minus pi SC. So, when the series field flux increases, mean the total flux will decrease. The total flux will decrease. So, the flux decreases mean speed will increase, because speed and flux is inversely proportional to each other. So, when the flux decreases, the speed will increases. See this, the speed will increases. So, this is the no load speed, this is the loaded speed. When the load increases, armature current increases, at that time the speed of the motor keep on increases. So, this is decreases in the previous case, cumulative compound motor, the speed is decreases, but here the speed is increasing. So, that is due to both are in inversely proportional, speed and flux are inversely proportional. Now, we will go to the third characteristic, speed versus armature torque, N versus TA. So, this is drawn from the previous two curve by finding the different values, speed and armature torque. For the different value of armature current, we can draw the graph between speed and armature torque. So, this is almost same as previous case. When the torque increases, the speed also increases. This dotted line is the no load speed. When the load increases, the speed also keep on increases. So, in this video we discuss about the characteristics of a compound motor. There are two types available, cumulative compound and differential compound. Cumulative compound mean fluxes are added together, differential compound mean fluxes are oppose each other. Subscribe this channel for more videos and notification. The soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.